Hi, my name is Bob Beechell. Now in this video about R, I'm going to be looking at what is probably the most important type of object in R, and that's a data frame. Now data frames are the main way in which you store your data set in R. They're essentially like a spreadsheet in that they have columns of variables and rows of cases, and when you import a data set into R, then it in general goes into a data frame. So it's important to know how to use data frames and how to manipulate them and deal with them. So let's have a look at data frames. Now you can create them manually as well as by importing data. So here I'm going to first of all create a couple of variables, a couple of vectors, x and z. So x here, which is as you can see, a numeric vector, and with 5 components, and similarly z. X has floating point numbers, and z has integers. And the other thing I should point out about data frames, of course, the columns do not all have to be the same type. They can be numeric vectors, they can be character vectors, they can be factors, which of course is often the case with your data set. Now to create a data frame from these two variables, here's the syntax. It's, as you'd expect, data frame, it's data dot frame, and then in brackets you list the vectors that you want to go in there. So and I'm assigning that to a variable df. So there's my data frame. Let me print it out. And as you can see, essentially it's a spreadsheet, 2 columns with the 2 variables, the 2 vectors, and here are the rows, which are the cases, which are numbered sequentially. Now if I look at my environment here, you'll see the data frame here. Data frames are listed under a heading data here, that is if you're in the list view, and vectors and matrices are under values. If you see there's a disclosure triangle here, if I click that, it shows me the actual variables that are in my data frame, 2 variables, 5 observations each, and actually gives the names and lists the elements. Obviously if this was a lot longer it won't list all of them, but it'll give you an idea of what's in there. If you change to the grid view here, this confirms that df is in fact, of course, a data frame, and these are 2 numeric vectors. Let me go back to list view. Notice this little icon here. This enables you to view your data frame, your data set, in a separate tab up in the source editor. So let me just put this back so that I can see the source editor as well, and I'll click this icon, and as you can see it's opened up another tab with the name of the data frame and with a spreadsheet type list showing of the data frame of the data set. And you can in fact reorder, you can sort the variables, sort the cases by each variable here if you wish. Notice that clicking the icon here ran a command view, so you could in fact have type that command into your code here, put view brackets and then the data frame, and that would achieve the same thing, but I tend to just use this little icon here. Let's have a look at the structure of this data frame, and as you see it gives me basically the same information that I have down here. It tells me it's a data frame, 2 variables, 5 observations, those are the 2, and those things. Notice the $signs here, and the reason for that is that a data frame is also a list. So you can access the variables, the columns here, using the notation, using the way that we did with lists, using the $sign and the name of the variable, as we'll see. Additionally, a data frame is also a matrix, which means you can use matrix methods that we've looked at in the matrix video. So the fact that data frame is both a list and a matrix means it's very, there are quite a number of different ways in which you can access the data in there, as we'll see. If I use the summary summary command on this data frame, well, as you can see, because it's a matrix with two vectors, two variables, two numeric variables, I get the same information as I did when I was summarizing a matrix. Key point, of course, is that unlike a matrix, a data frame can have variables, can have columns of different types. They don't all have to be numeric. You can have character vectors and logical vectors and so on, as we'll see. Okay, so let's have a look now at how to add additional columns, additional variables to a data frame. So what I'm going to do is add a additional column, additional variable that contains text. It's a character vector. Now, as I mentioned, since a data frame is a list also, I can use the list method, the way that we add additional information to a list, which of course involves typing the name of the list, or in this case the data frame, a $, and then giving that additional vector, additional element, a name, a tag. It's called in list, but here it's essentially a variable name, so I'm calling it C, and then I'm adding this vector. So as we'll see, if I run that command, it will have now added an additional column, an additional variable called C to my data frame. I can confirm that by printing it out. And there it is. So as we can see, a data frame, unlike a matrix, can contain columns, vectors, variables, whatever you want to call them, of different types. Essentially just like a spreadsheet. Notice the column names here, which are the names of the variables that I've given them. If you wanted to retrieve those column names in order to have a look at them, you can do that with the call names command or function. So here, running call names brackets df will return the column names as a set of text, so it returns a character vector. Most likely, in fact, what you'd want to use call names for is to change the names. What you find here the names are okay because they're the names I actually gave the variables. But what you find is that when you manipulate a data frame and create additional columns, sometimes the name given to that new variable is not particularly appropriate, and you need to change them. You can do that with the call names function, but in this case, rather than just returning the value, you assign a different value to it. So as you can see, since it returns a column, a character vector, that's what I need to assign to it here. So I'm going to change the variable names here, the column names, to variable 1 or var1, var2 and var3. So let me do that. And then if I show it again, as you can see, they've changed now. You can also add additional variables and columns to your data set, to your data frame, using the matrix method, the matrix function cbind, which we used when we were looking at matrices. This is because, as I've said, of course, that a data frame is also a matrix, so we can use matrix methods. So let me create a variable here, variable 4, which is going to be variable 1 times variable 2. Notice here I've used the list form here, the form of accessing elements, variables in list with the $, since a data frame is a list. So that will create a variable 4, which is variable 1 times variable 2 multiplied together. By row, of course, so it would be 2.3.4 times 11, 5.66 times 13, and so on. Okay, so that creates that. I can now add that to the data frame by using the cbind function, which we've seen for matrices. So I'm using that. Again, if I then print it out, you'll see that is indeed added a column, variable 4, which, and these values, of course, these two, variable 1 times variable 2 multiplied together. Let's just check the structure of that now. So now, of course, we have a data frame with 4 variables, 5 observations on each. Those are the variable names, column names. That tells you the type of data in each variable, in each vector, each column. And so that's what we've now got. If I run the summary command this time, well, obviously the numeric variables again get the same information here as before, but of course variable 3, which is a character vector, that simply tells me how many there are and that it is a character. Okay, so let me notice, of course, down here that as I created variable 4, that's now been added to my list of variables. Let me just maximize the editor window. Okay, so what we need to look at finally is how to subset data frames, how to filter for specific columns, or specific rows. Again, since we know that a data frame is both a list and a matrix, we can use either of those methods that we've seen before to subset or filter. So here I'm first of all going to use the list method, the list style of accessing accessing variables with the $sign. So that will give me variable 1 here, which returns as a vector, of course. Now, if I want to return if I want to return the data set, the data frame, minus column 3, then I use this notation. Again, we saw this before. So this, of course, will return all the rows minus column 3. So it returns the columns minus column 3. There we go. So I've got columns 1, 2, and 4 now. Variables var1, var2, and var4. Here I'm going to use a condition, again as we saw with matrices. So this time I'm returning rows, and I'm only returning those rows where the values in column 1, this is column 1 of course, are greater than 10. So that should be rows 3 and 4 here. And I'm assigning that to another variable, dfg10. So let me run that command. Now let's print it out. And as you can see, it has returned just simply rows 3 and 4 where the values in variable 1 were greater than 10. So that's using these 1, 2, 3 commands here, essentially using the matrix style, the matrix method of subsetting. Let's now show how we can use the list approach as well. So here I'm going to return rows again, because the comma, remember, means all columns. So I'm returning rows, and this time I only want those rows where the value in variable 3, in column 3, is female. So that should return rows 2, 3, and 5. Notice this is actually quite I think a better, a neater way of subsetting and filtering than using this method here. I think it's easier to do. So let me run that. And as I said, I'll get rows 2, 3, and 5 where the value in variable 3 is female. So this is a very good way of subsetting. When you have a big data set, you often only want to then concentrate on a certain subset according to some condition. So here, if this was a data set involving values for men and women, then I only want to concentrate on the responses or the values appropriate to the females in the data set. Then that's how I would subset it. In fact, there's possibly an even easier way than using this approach. Because remember here, one of the things you must remember, of course, is that final comma to get all the columns. If you don't do that, it doesn't work correctly. So in some ways I prefer to use this approach here, which is use the subset function, which makes it very clear what I'm trying to do. So I'm wanting a subset of my data set where I'm only looking at males here. So notice the syntax, I'm assigning this and then to a separate variable. So it's subset, and then in brackets the data set, the data frame, comma, and then you simply specify the variable that you want to subset on, you want to filter by, and the value in that variable. Very important to notice here that you have to put a double equal sign in R in order to compare to establish a condition involving an equality, whether something's equal to something. Use a double equal sign. If you put a single equal sign there, it thinks you're trying to put male into var3. What you're testing is see which values in var3 are equal to male. So that double equal sign, very important. So let me run that. So let me just check what this should return. Of course, it should return rows 1 and 4 only. Notice no need for any comma here to specify all columns. It does that. This, I think, is a simpler way of doing it, a more intuitive, a more obvious way than perhaps this. So let me do that. And if things have worked out as I expect, it should return this data set now. This data frame should contain simply rows 1 and 4. So let's finally display that, and there we have it. Notice, of course, in these cases here, then you are returning, well, you're not returning just one row, you're not returning a vector, you are returning a data frame. We can confirm that if we go back down to environment, and as you can see, those are those 2 additional data frames that I've now created. Okay, so that shows you how to handle data frames.